আছে, একটু ওপেন করা যাবে স্যার?
At this moment, I don't have the assignments, but you can directly tell me what is the question.
স্যার ওইখানে হচ্ছে ওই ইকুয়েশনটাই হচ্ছে আমি আমি একটু স্যার বের করি।
Yeah.
এক্সপেন্স স্যার ইন্টিগ্রেশনের হচ্ছে রিডাকশন ফর্মুলায় ইন্টিগ্রেশন অফ 10 টু দি পাওয়ার 10x টু দি পাওয়ার n, এইটার রিডাকশন ফর্মুলা স্যার দেয়া আছে হচ্ছে -10 টু দি পাওয়ার n-1 ইনটু সরি 10x টু দি পাওয়ার n-1 ডিভাইডেড বাই n-1। এখানে কি স্যার 10x টু দি পাওয়ার n-1 ডিভাইডেড বাই n-1 এর আগে কি স্যার মাইনাসটা হবে?
Okay, Akash, you were present in my last consultation, right?
ইয়েস স্যার।
So you must have seen that I have provided one whatever I have summarized on that consultation. I have given all these things to you. So
Yes.
here is the formula. Already it is in your email. Okay, you can see this is the reduction formula.
এখানে স্যার মাইনাস তো স্যার নাই, তাহলে কোশ্চেনে হচ্ছে মাইনাস দিছে।
Yeah, this is correct. This is correct.
তাহলে স্যার ওইটা কি করব স্যার? ওইটা করলে তো অন্যরকম অ্যান্সার আসছে।
That was wrong. Maybe there is a typing mistake. Okay.
জি স্যার, তাহলে কি স্যার ঠিকটা ধরে অ্যাসাইনমেন্টটা করব?
Yeah.
আচ্ছা স্যার, ঠিক আছে, থ্যাংক ইউ।
Okay. Any question from assignment?
Assalamualaikum sir.
Muslim Tamim, how are you?
Sir, reduction formula একটা reduction এর সময় একটা math problem ছিল স্যার।
Yeah, you can tell. From which set?
স্যার এটা হলো স্যার assignment 1 এর G set.
We are discussing assignment 2, not assignment 1.
স্যার assignment 2 এর একটা ছিল, ওটা হলো স্যার G set এরই integration of cos x to the power 6 dx. এটার স্যার আপার লিমিট হলো π/2 আর লোয়ার লিমিট হলো 0.
This one?
0.
Lower limit 0, upper limit?
π/2.
π/2. Have I written the correct one?
Yes.
Okay. So you can see that we have the function cosine x power 6. Is that okay?
Yes.
So for this, you don't need to remember the formula, but what we can do here, we can apply this technique. That is, if we have cosine into cosine power nx dx, then we can use this formula. Okay.
Yes.
So using this formula, you can see that in this here we have power n. That means whatever we have here, we have power 6. Is that okay?
Yes.
So let me apply that formula. You can see here we have 1 over n. That means we can write 1 over 6. Then cosine n minus 1. So cosine 5 minus 1. Sorry, it is 6 minus 1 x d sine x. And then plus n minus 1, that is 6 minus 1 over 6. And then integration of cosine n minus 2 cosine 6 minus 2 x dx. Is that okay, Tamim?
Yes.
So we are just applying the direct formula. It is called reduction formula. So you don't need to memorize all these formulas, okay? Because you are solving the problems from your home, so that's why you can directly have a look on the formulas and you can apply that formulas. Okay, so 1 over n, and this time n is equal to 6. So that is the thing we are going to apply here. So what we can do here, 1 over 6 cosine 6 minus 1, that is 5x sine x, plus 5 over 6 cosine power 4x. So why we use reduction formulas? That is a big question, because we know that integration of cosine x dx, that is equal to sine x. We also know what is the integral of cosine square x dx. We can apply trigonometric identity, but things will be critical if we have cosine cube, if we have cosine to the power 4. So for all these things, we can apply reduction formula. Reduction formula says that we have to reduce the power of any trigonometric function. Here we have cosine power 6, so our target is to reduce the power. You can see after applying the reduction formula, we are able to reduce 6 to 4. Is that okay?
Yes.
So now again we can apply the same technique for this part. Our target is to find the antiderivative or answer of the integration. So that's why the same concept will be applied here, but what is the value of n this time?
4, sir.
This time n is 4, because you can see that here we have n equal to 4. So again the same formula will be applied. That is, here we have written 1 over n, that means 1 over 4 cosine 4 minus 1 x sine x plus 4 negative 1 over 4 cosine 4 negative 2 x dx. Is that okay,
Yes,
everyone?
sir.
Yes, sir.
So, so 1 over 6 cosine power 5 x sine x. In my last consultation, I have discussed the theoretical concepts. That's why today I am directly going to problem solving part. Okay. So 5 over 24, we are getting cosine 4 negative 1, that is cosine 3 x sine x plus. Now we can see that 4 negative 1, that we can write here 3 over 4. And now we are getting cosine squared x dx. So for this, we know that 2 cosine squared x, that is equal to 1 plus cosine 2x. We can apply the same technique, or we can apply the reduction formula also here. Okay. So since we are applying the reduction formulas, we can apply again. So here you can see that at first we had power 6, then after applying reduction formula for cosine, we were able to reduce it to 4, and then finally we were having 2. Is that okay?
Yes, sir.
So the same technique will be applied for this one. So let's apply. So from previous part, we have 1 over 6 cosine or 5x sine x plus 5 over 24 cosine cube x sine x. I'm trying to make you understand what is the concept, but do have a practice at your home. Okay, you will understand the things. So 3 over 4. Now we are going to integrate cosine square x by the same technique. Okay, so we can apply here again the reduction formula. So 1 over 6 cosine to the power 5x sine x plus 5 over 24 cosine cube x sine x plus 3 over 4. We can apply the reduction formula also, or we can apply the trigonometric identity, because integration of cosine x, we know it is sine x. Integration of cosine square, we also know if we can apply the technique, that is, we know that 2 cosine squared x is equal to 1 plus cosine 2x. So things are up to you. So just tell me which formula we can apply here.
Sir, reduction formula, sir.
Okay, let's apply reduction formula, but we can also apply trigonometric identity for this one. Is that okay?
Yes, sir.
Okay, so this time you can see n is 2. Is that okay?
Yes, sir.
N is 2. So here we have 2. So again the same formula will be applied. That means let me erase this one. So plus 3 over 4, 1 over n. That means 1 over 2 cosine. You can see cosine 2 negative 1, cosine 2 negative 1 x sine x, and then plus n negative 1 over n. So here 2 negative 1 over 2, then cosine, integration of cosine n negative 2. So integration of cosine 2 negative 2 x dx. That is our last step. Our target is to find the answer of the integration that is mathematically called antiderivative. Okay, so we have to remove the integral sign. You can see in this line, in this equation, we have only one integral sign. Is that okay? Can you see?
Yes.
So we have to find the answer of that. So finally 1 over 6 cosine to the power 5x sine x plus 5 over 24 cosine cube x sine x plus 3 times 1, 3 over 8. Now if we calculate this one, it will be cosine x, cosine power 1. That means just we can write cosine x sine x. Is that okay?
Yes.
Plus 2 negative 1 is 1 over 2 integration of cosine, integration. Now we are getting 2 negative 2, that is 0, cosine power 0 x dx. So now tell me, what is the value of anything power 0?
1.
Anything power 0 is 1. So I'm not writing this one directly, I'm writing it is integration of, okay,
1.
1. So 1 over 2 integration of 1 dx. Finally it is okay. That means we will get the same thing here, plus 1 over 2, and now integration of 1 with respect to x, that is, you know, it is x. So finally it is our required answer. Okay,
Yes.
so here we have applied reduction formula to find the integral this one. Since you were solving the assignment problems from your home, so you can directly have a look on the formulas, and already in my last consultation I have provided these formulas to you. But those who didn't have this one, you can have a look on the reference books, and I have told you that you can download this book, that is calculus written by Howard Anton, that you have used the same book in your math 110. And also we need to know differential equation, that is from this one, differential equation written by Danish Jill. So these two reference books are helpful for this course. Okay, so okay, we have solved one problem from assignment. Let's do another one. Do you have any problem now?
Yes, sir. I have a problem with, sir, partial fractions. Is like there is one partial fraction for the linear and a quadratic, for the linear
Okay.
for numerator and a quadratic for denominator.
Okay.
My problem is, sir,
First of all, tell me your question.
sir, the question is, sir, I am having problem with assigning the values. Like at the end, you are assigning C and D. So the in
No
the video,
problem.
the
I will
file.
try to solve. Okay, tell me.
Okay, the sir problem is, sir, from set I. It's like integrate I slash x square plus x minus 2, like partial fraction.
X square.
Wait, I'm gonna just make it up.
What
So
you
it's
have
one slash, sir. It's one slash x square plus x minus 2, like 1 and divide x square plus x minus 2.
Is that
No, so
okay?
there's no, that's not the one, sir. X square minus x plus wait, sorry. X square minus by x square plus x minus 2. Sorry, I'm really sorry. I opened
Plus
something
x
else.
minus 2. This
Yes,
one.
yeah.
Okay.
This one. Yes, sir. The
So
thing is,
first
sir,
of,
I've done everything, but the problem is, sir, I'm having problem with assigning it. It's C and
okay,
D. Like that's the
no
problem.
problem. So first of all, In my last consultation, I have discussed the same topics. That is, if we have rational function means a function that has numerator, denominator. In numerator, we have a function f of x, and in denominator, we have g of x. Is that okay? So,
Yes, sir.
so we have to look at the denominator. So, rational function can be classified into two categories, that is proper rational and improper rational. What is proper rational? If the degree of numerator is less than the degree of denominator. You can see here we have x power 1 and in denominator we have x power 2. So you can see that this one is less than this one, so this is proper rational. Similarly, here we have x power 1, and if we multiply this and this, we will get x squared. So what we are getting, the upper part has lower degree than the lower part, so that means it is proper rational. What is improper rational? If we have if the degree of numerator, if the degree of the upper part is greater than or equal to the degree of denominator. You can see here we have x power 2, but here we have x power 1, that means 2 is greater than 1, so this is called improper rational. Or we have x power 1, here we have x power 1, these two are same, so that means these are called improper rational functions. Okay, so theoretically these are called rational and rational functions, and we have to know how we can decompose all these things. So whatever function we have in denominator, that should be factored out at first. Is that okay? So factoring can be of these three types. If we have x minus a power 1, x minus b power 1, x minus c power 1, then with every factors, x minus a there will be a constant, x minus b there will be a constant, x minus c there will be another constant. But things will be complicated if we have higher power. See, we have x minus a, x minus b. For x minus a we have one constant, for x minus b we have one constant, because we have x minus b power 1, x minus a power 1. But with x minus c we have power 2. So what we have to do here, at first we need to keep x minus c with 1, that means this will contain one constant, and then we have to take the second one, x minus c is squared with a constant d. This is the process how we can decompose rational functions. And the third step is we may have the denominator just like this, x minus a, x squared negative b. Is that okay? So
Yes, sir.
for x minus a, since it is just looking simple, so x minus a power 1, there will be a constant. But for x squared, you can see this time we have the factor as quadratic form. So for this we will have bx plus c. These are the theoretical concepts that how we can decompose, okay, how we
The
can
fraction
decompose
case. Yes,
rational
sir. The
functions.
fraction case. Yes, sir.
Yeah. So for this problem, okay, for this problem, you're definitely sure that the function that is inside here is rational function. Now I want to tell you, I want to ask you, what type of function is this? Is it proper rational or improper rational?
It's proper, sir.
It's proper rational, because in upper part we have x power 0. X power 0 means
0 and
1, and here we have x power 2. So this is definitely a proper rational function. So we are saying that this is proper rational. So first thing is we have to factor out this function. That means we have to factor out the denominator. So how we can factor out? Can we do this one?
Yes, sir. Just middle terming it.
Yeah. So integration of 1 x times x plus 2 negative 1 x negative x positive 2. Is that okay?
Yes, sir. It's
So
okay,
here
sir.
we are getting 1 over x plus 2 x negative 1 dx. I am taking directly problems from your assignment so that you can understand what are the things. Okay, so here finally we have found the factor form of that proper rational functions. Okay, so
Yes.
here we have the proper rational function. Now you can see all the factors with power 1. Okay, all the factors we have here with power 1.
One, sir.
So
Yes, sir.
that means which technique will be applied out of these 3?
The first one, sir.
First one, because first one has power 1, power 1, power 1.
Yes,
So
sir. Yes, sir.
it doesn't matter that we have here x negative a, we may have x positive a, okay, x positive b, x positive c. So all the factors with power 1, that means all the factors separately will take one constant. So we are going by this way. That means we have to integrate this function, but before things are very complicated if we want to integrate by this one. So that's why method of decomposition is important. Okay, so we have to
Okay.
decompose the function. So let's decompose the function. So if we decompose, that means 1 over x plus 2, 1 over x plus 2 times x negative 1 equal to ay. So x plus 2, at first x plus 2 will take a constant and x negative 1 will take another constant. Is that okay?
Yes, sir.
So now recall your school level studies. What you have done, you have just multiplied. So if we multiplying x plus 2, x negative 1 on both sides. Okay, so
Yes, sir.
everyone, please try to find problems from your assignment, because in last consultation I have already told you that today the total consultation will be based on your assignment problems. Okay, because this is my last consultation for this week. And okay, so try to find out your problems. I will try to figure out what is happening. Okay, so here we have x plus 2, x negative 1. The term that you have in the left side denominator, that should be multiplied on both sides. This is the concept. You can't multiply,
Yes.
you can't multiply x plus 2 only, x minus 1 only. You have to multiply the term that is in the left side denominator. That should be multiplied on both sides. That's why I have taken this one. Okay, so if we multiply this one here, so what we'll get? We will get 1. Is that okay?
Yes, sir. It's that. That's okay.
So 1 equal to, and if we multiply the same thing here, so x plus 2 and x plus 2 can be cancelled. We will get just a times x negative 1. I hope everyone is understanding. Okay, and b times x plus 2. Clear? Try to respond. Okay, otherwise.
Yes, sir.
Okay, so here now we have to, our target is to find this constant a and this constant b, so that we can easily integrate this one and this one. Okay, so first of all, let me take another page. So here we have found 1 equal to a times, this is our relation, a times x negative 1 plus b times x positive 2. From the very childhood you are practicing with this sign. Okay, this is called equivalence sign, but we can also use equal sign. Is that okay? Can you
Yes,
figure
sir.
out what I am doing here? Okay,
Yes, sir.
so here we can input any value of x at first, just to, so we can make an assumption here. If we input x equal to negative 2, automatically this part will be cancelled. Is that okay?
Yes, sir. That's okay, sir.
So we are going to input x equal to negative 2 at first. So from this part, we are getting 1 equal to a times negative 2 negative 1 plus, and this part will be 0. Okay, because we are inputting negative 2, so negative 2 plus positive 2, we are getting finally 0.
Okay, sir.
So negative 3a and plus 0. So finally we are getting negative 1 equal to negative 3a So finally it is a equal to -1/3. Is that okay, my dear? Okay.
Yes, sir. That's okay.
So the same concept can be applied for finding b. So now let's input. You can easily input x equal to 1 here. So automatically this part will be vanished and we will get b. So we are going to input 1 now. So from here 1 equal to a times 1 -1 plus b times 1 plus 2. We are plugging the value of x equal to 1 where we have x. In the place of x, we are inputting 1. Is that okay? So
Yes, sir.
1 equal to, here we are getting 0 plus 3b. So 1 equal to 3b. That means b equal to 1/3. Finally, we are able to find the constants a and b from this relation. So let's come to this one. From this one, we have decomposed this function as a by something and b by this one. So let's come from that part. So finally, do you understand?
Yes, sir.
1/x+2 and x -1. So 1/x+2 x -1 equal to a by x +2 plus b by x -1. Now we are going to input the values of a and b. So here a is found to be -1/3 and b is found to be 1/3. So let's input -1/3 x plus 2 plus 1/3 x -1. Clear?
Yes, sir.
So in left side we have 1/x plus 2 x -1. So somehow we have completed our 50% task or 60% task. Don't forget that we have to integrate. Okay, we have to
Okay, sir.
integrate this function. This is our main task. So integrating rational functions is complicated. That's why we have used the concept of decomposition. Okay,
Yeah. Okay,
so
sir.
integration of, now I am taking integration. So integration of left side will be separately this here. Okay, now it is easy to solve. Do you
Okay.
understand?
Yes, sir. I
We have
understand, sir.
to
Thank you.
integrate the left side, so we are distributing the integral sign on each terms on the right side. Okay, so
Okay, sir.
here you can see that 1/3 and -1/3 are constants, so we can pull out these constants before, plus again 1/3 1/x -1 dx. Now we need to figure out the answer. So you know that the formula that we have, I have already provided you the formulas. That is integration of 1/x dx, that is equal to natural log of modulus x. It is, you often do a mistake, you just write ln of x, but that is wrong. Try to use modulus. Okay, natural log
Okay, sir.
of modulus x, that is ln x or ln x. Okay, so here we have x plus 2 and x minus 1. So now I can directly find the answer, but for your better understanding what is the concept is working behind, I want to tell here. That is, in my first consultation I have told you, I have discussed about u-substitution method. Okay,
Okay, sir.
so we can solve these problems by using u-substitution method. So for the first integral, this one, what we can consider, we can consider x plus 2. If we consider x plus 2 as u, whatever term you are considering, The second step will be differentiation. That is the process of u-substitution method or substitution method. We are differentiating both sides in terms of this variable x. Okay? So we are getting differentiation of x is 1 and differentiation of 2 is 0. So d dx of u, finally we can write du dx. So that means we are getting dx equal to du. So what we can write here, we are converting x plus 2 to u. Is that clear? And
Yes, sir. That's clear, sir.
dx is found to be du. Okay, similarly for the second one, you don't need to show all these steps. You can directly write it is, I can directly write the answer. It is natural log of x plus 2, and here we have 1 over 3 natural log of x minus 1. But since you are the beginners for math 120 course, that's why I am going to describe the things. So similarly, the same thing can be applied here. Here we have x negative 1. So let's take now for the second one. I am now discussing the second one. X negative 1 as v. Again, after differentiation, we will get dx equal to dv. Okay, I have skipped all the terms here. The same thing has been applied. So
Okay.
plus plus 1 over 3. Now integration of 1 over. So what you have considered for x minus 1? X negative 1 is considered to be v. Okay. And for this dx is found to be dv. So finally, now it is going with the direct formulas. That is integration of 1 over x is ln modulus x. So 1 over u will be ln modulus u. 1 over v, ln modulus v. Is that okay?
Yes, sir. That's okay, sir.
Okay. So finally, we can write the answer. That is, it is negative 1 over 3 ln of mod u plus 1 over 3 ln of mod v. Clear? So
Yes, sir. That's clear.
since this is indefinite integral having no lower limit and upper limit, that's why we have to input a constant c. So for the first integral, we will have constant 1, and for the second integral, we will have constant 2. But you know that c1 plus c2 is again a constant. Is that okay?
Yes, sir. That's okay, sir.
So for the two integrals, finally we can input a constant c. But still our answer is incomplete, because we have to get back to x. Okay, u and v are our consideration, but we have to get back to x. So let's input the final answer. The final answer will be, okay, let me take another page. Negative 1 over 3 ln of, so what is u here? X plus 2. Is that okay?
Yes, sir. That's okay. X plus 2, sir.
And plus 1 over 3 ln v. So 1 over 3 ln x negative 1. And for the two integrals, we are using only one constant c. Finally, this is our final required answer. Okay.
Thank you, sir. That will be all, sir. Thank you.
So whatever process I have applied here, you don't need to show all these things. But this is the very basic of integral calculus. Okay.
Okay, sir. Thank you, sir.
You can directly write your answer if you can do. Okay. So next question.
Sir,
Yeah.
sir, I have completed some tasks, sir.
Yeah, tell me. What's your problem, Jubair? Hello.
Yes, sir.
Yeah. What's the problem?
Someone.
Okay, just tell me. I am trying to solve.
Sir, sir, I don't know, sir, if this is correct. So can you please check it out?
Can you please just pronounce
Yes.
what you have here? Okay, integration of cosine cube x dx, and integration, it is the limits are 0 to pi by 2. Is that okay?
Yes, sir.
And you can apply a reduction formula or whatever process you have applied here, that is also correct. But uh, you can also apply reduction formula here, just like this one. We have solved for cosine to the power 6, and for your question you have cosine power 3. Yeah, you can do.
Yes, sir.
No problem. No problem.
Okay, sir.
Okay.
Yes, sir.
Process is correct. Yes, 1 minus sine squared, and then yeah, 1 minute. You have considered sine x as z. Okay, good.
Yes, sir.
It's okay. Okay, Jubair, no problem. Concept is okay. Yeah, sine x, and finally apply fundamental theorem of calculus. Yeah, okay, you can do.
So here's the answer, sir. Oh, and then I can also use the reduction formula to solve it.
Yeah, you can also use the reduction formula. Okay.
Okay.
And okay,
Yes.
for your information, I am using this one. Okay, your problem is?
Sir, here is another one, sir.
Okay, just I am making sure your answer. Upper limit is pi over 2, right?
Yes, sir.
And you have cosine x power 3.
Yes, sir.
So your answer finally should be
2 by 3.
two by 3, right?
Yes, sir.
Okay, yeah, it's okay. Correct.
Sir, I have another question. Like in the question paper, they said that let substitute u equal to root over x minus 1. But sir, how can I simplify u equal to root over x?
From which
X square
set?
plus 1.
From which set? This is
Sir, set f, sir.
set F.
F. Yes, sir. Number 3,
Okay.
sir.
What is your question?
First, here is the problem, sir. Upper limit is 1, lower limit is 0, x is cubed
Yeah.
by root over x square plus 1. Then here, sir, it says that substitute this by integration by parts, and the substitution u equal to root over x square plus 1. But sir,
Yeah.
here I have just used this one, not u equal to root over x square plus 1. I have used u equal to x square plus 1.
Yeah. And then okay, show me your left side. Okay. Finally, your answer. Okay. Okay. Last answer. Finally.
Sir, 0.195.
0.195. The process that you have applied, that is okay, and you have considered x
Sir,
square plus 1 as u. Is that okay?
yes, sir.
Yeah, that is okay. You can also take root over x square plus 1. No problem.
But
But
sir,
it's
how I'm
going to
going
the
to
same
sir
result.
simplify it, sir? There is root, sir.
Okay,
How I'm going to derive it?
already you have solved this one, but I am going with this problem. You know that differentiation of, suppose you have ddx of root over x. You know the differentiation, it is 2 root over
Yes,
x,
sir.
1 over 2
1
root
by
over
2
x.
root x.
Okay, and now if we have ddx of root over x squared plus 1, we can apply chain rule. So here it is not going with the direct formula, this one, but what we can consider, the inside part can be considered as x. So for this we can apply 1 over 2 root over that one, and the term that we have considered, that should be again in differential form. Is that okay?
Yeah, I got it.
So 1 over 2 root over x squared plus 1, and from here we are getting
2x.
differentiation of x squared is 2x and differentiation of 1 is 0. Finally 2 and 2 can be cancelled. We are getting x over root over x squared plus 1. Is that okay? You can also go by this way.
Yes, sir. I got it, sir.
Okay,
Sir,
so next
if
question. Yeah,
sir, is there will be a problem if I solve this by this
uh,
term?
what is your question?
So in the question it says that the substitution u equal to root
Yeah,
over
that,
x square plus 1.
that means you have been asked to use u equal to root over x square plus 1.
Yes, sir.
So you can't avoid this one. Okay, you have to go whatever you were instructed to
Okay.
do. Okay,
Okay,
and
sir.
I can see another part. Again go back to your question, main question,
Yes, sir.
the PDF file. Yeah, and also part A is saying that use integration by parts. Okay, you can't avoid
Yes, sir.
also that one. You have to solve the same problem by two methods. One is integration by parts and another is using substitution method. Okay, and you will get a same result, but integration by parts is quite difficult for this one, what I can say.
Sir, I have used the integration by parts.
Okay, your answer should be the same one, 0.195.
Here, sir. Here is the integration by parts formula.
Okay, is there anybody who have the same set F here? If you have the same set, then I will discuss this problem here. Okay, you are showing your integration by parts method.
Yes.
Okay, show the upper part. No, it is not integration by parts, Jubair. It is just method of substitution.
Okay.
Integration by parts means this one. Let me show. Integration of uv dx, then u integration of v dx, differentiation of u, integration of v dx. This is called integration by parts. Okay.
Yes, sir.
Okay, so you have to apply the same technique, integration by parts. This is just method of substitution.
Okay, sir.
Okay, do you want this answer by using integration by parts?
Sir.
Yeah.
Oh, sir. I get it, sir. I get it.
You have to
Sir,
apply
I
this.
have a question, sir.
Yeah, tell me.
Sir, in here, which one is the U answer? Which one is the V?
That is a big question. Okay, so u integration of v dx, then
Because, sir,
differentiation.
the functions are the same, sir.
First let me finish. Differentiation of u, integration of v dx, and then total integration. This is called
Yes, sir.
integration by parts. Okay,
Yes, sir.
so for your problem is integration from 0 to 1 x cube root over x squared plus 1 dx. So this time I can, whatever I have seen from your question, that part B is saying that use substitution method, right? So already
Yes,
you
sir.
have done that one. And
Yes, sir.
part A is you have to apply UV technique. Is that okay?
Yes, sir.
So for you, just let me decide which part can be taken as you. It is up to totally up to our practice. Okay. So here we can forget about these limits now. Okay. Can we do this one? X cube x squared plus 1. We can take the reciprocal of
Yes, sir. Minus of.
this one. Okay.
Yes, sir. Yes,
So
sir.
now if we consider this one as u, that is, we are going with this definition, integration of uv dx, that is equal to u integration of v dx negative integration of, sorry, differentiation of u integration of v dx and total integration. Okay.
Yes, sir.
Okay, or we can do by another way. Suppose I am taking x squared x over root over x squared plus 1. That might work. Okay, so first of all, consider this one as u and this one as v. So we are applying this concept. So x squared, that means here u. So u integration of v negative total integration and differentiation of the first one u. So differentiation of x squared integration of v and total integration. Is that okay, Jubair?
Yes, sir.
Okay, so what we are getting here, x squared. Okay, first of all, you can see here we have a complicated integral, and here we have
Yes,
another, the same one. Okay,
Yes, sir.
so we can think about by this way, that is x squared. We can consider this one as integral I. Negative differentiation of x squared is
2x.
2x and same I. Okay, dx. So finally we can write x squared I negative 2 is constant, 2 can be pulled out, so x I. Clear?
Yes, sir.
dx. So what you have to do, just for the simplicity of the calculation, we can find I at first, then we can plug again here. Clear?
Yes, sir.
So let's find this one, and then finally we will input the same part here, then we'll get the final answer. So now our focus is on this. Everyone, do you understand what I am saying?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So it is from set F, right, Joel?
Yes, sir.
But it doesn't mean that you are just from set F and everyone don't need to do this one, but you have to know what is going on. Okay.
Yes,
So
sir.
let's focus on this part. So then we'll move to this one. Let's say this is equation 1. Okay, so we'll get back to here again, but our focus is to find integration of x over root over x squared plus 1. And just to solve this one, we can apply u substitution method, we can apply z substitution method, what you can do. Okay, it is allowed. But since in your given question you have been asked to use integration by parts, so you can't avoid this one. Jubair, do you understand?
Sir,
Okay.
which
We have
one I
applied-
am going to avoid?
Yeah.
Yes, sir.
Already,
Yes, sir.
already we have applied u substitution method. Sorry, integration by parts. That means integration of uv. So you are
Okay.
getting full marks for this part. Okay. Now you have to solve
Okay,
just.
sir.
But that means whatever you are instructed to do, you are doing the same technique. Okay. Now for this one, so we can think about u substitution method here. So we can we take x squared plus 1 as u?
Yes, sir.
So
Then 2x equal to u
once we have
v.
considered, then the second step will be differentiation. That is called u substitution method. Okay, you don't need to show
Yes,
all
sir.
the steps, but the same technique I have discussed for this problem. That is, whenever we are considering, second step will be differentiation. So you can't avoid the basic concepts. Okay, if we
Yes, sir. Yes, sir.
apply the basic concepts always, then there will be no problem in solving the integral problems. Okay, so finally here we have x dx. So that means next step will be keeping x and dx terms on the left side and on right side u
U
and
then v.
constant terms. Okay,
Yes.
is there anybody who was present in my last consultation? They know that I have discussed the same thing on that consultation. Okay, that means we have to keep, whenever we are applying u substitution method or substitution technique, we have to keep x terms on left side and u and constant term on the right side. Clear? So let's come from here. So we are getting root over, so square root of x squared plus 1, it will be square root of u. Clear?
Yes, sir.
And x dx is found to be
du by
du over 2. So since 1 over 2 is constant, we can bring before. So here we have root over this, and finally from this part we can write 1 over 2 directly. The reciprocal will be u power negative 1 by 2. Clear?
Yes, sir.
So you know that 1 over 2. Now we can apply. Have I written the correct thing? Yeah.
Yes, sir.
So you know that integration of x to the power n dx, that is nothing but x power n
X
plus
power n
1 by
plus
n
1 divided by
1.
n plus 1. Yes, sir.
Yeah. So here we can do u power negative 1 plus 2, negative 1 by 2 plus 1 by negative 1 by 2 plus 1. Clear?
Yes, sir.
So finally we are getting 1 by 2. This problem is difficult.
Half by half.
And finally 2 and 2 cancelled. We are getting this one is
Root over
u
u.
power root over u, right? U power 1 by 2 or root over u. Finally get back to x. It is x square root over x square plus 1, right? Clear? And this
Yes.
is our I. You remember? This is
Yes, sir. I, sir.
I. So already we have found the first integral, that is I. Let's plug this part into this relation. Clear? Then we will get
Yes,
the
sir.
final answer. So again, coming back from the main question. So do you understand this problem is difficult?
Sir, mine one is easy, sir.
But you have been instructed to do, you have been instructed to apply integration by parts, so you can't avoid this one. And also
Yes,
second
sir.
part is substitution method. So here we have integration from 0 to 1 x cube. Can you please help? Here we have x squared plus 1 dx equal to, and we have established the relation, that is finally it is x squared I negative 2 xi dx, negative 2 x I dx. Clear? So now
Yes, sir.
let's input this one. So I we have found it is square root of
Root x. x square plus 1.
X squared plus 1. It is square root of x squared plus 1 negative
Yes, sir.
2 x times square root of x squared plus 1. Clear?
Yes, sir.
Dx. So you can see that in the first term, yeah, again, in the first term, you don't need to solve, it is already okay. But for the second part, you have to again consider either u-substitution method or integration by parts. Since we have applied u-substitution method from the very beginning, now we can directly use u-substitution method. So here you can see we can take, let's take x squared plus 1 as u. So ddx of x squared plus 1 is equal to du dx. So finally we are getting 2x equal to du dx, and then I have mentioned that you have to keep x dx on left side and on right side u and constant terms. Clear?
Yes, sir.
So negative 2, this one can be written as root over, sorry, we have already taken u, right? So let's take, it is
W.
w or v, no problem.
Yes,
Or
sir.
since the same part is here, so we can also use u. Is that okay?
Yes, sir.
Okay, so let's say it is u, and then we are getting du by 2. So from here you can see that 2 and 2 can be cancelled. We have just x squared root over x squared minus 1, and just this part can be written as u power 1 by 2,
Yes, sir.
isn't it?
Yes, sir.
Du. And finally x squared root over x squared plus 1 negative, and again we can apply the same technique, that is integration of x power n dx, that is x power n plus 1 over n plus 1. So u power 1 by 2 plus 1, 1 by 2 plus 1. Clear?
Yes, sir.
So what we are getting? We are getting x squared root over x squared plus 1 negative u power 3 by 2 over 3 by 2. Clear?
Yes, sir.
And let's get back to x, because we have to convert u to x. So here we have x squared plus 1. So finally x squared root over x squared plus 1 negative x squared plus 1, 3 by 2, 3 by 2. This is our final antiderivative, and don't forget that you have limits. Okay,
Yes, sir.
now input 0 to 1. So whenever you have complicated integrals, don't think about the limits at first. Okay, Jubair?
Yes,
Or
sir.
everyone?
I'll put the
Okay.
limit at the in the
At
last
the-
step.
Yeah, finally, whenever you have the final result, then
Yes, sir.
you can input 1 and 0. So now you can apply fundamental theorem, f of b minus f of a.
Yes, sir. Yes, sir. Yes.
Okay. So your answer will be same. What you have said, it was 0.195, right?
Yes, sir. Yes, sir.
It must be 0.195 for this process.
Yes, sir.
Okay. So next question from another set, Pratik Bhomik or Nias. Do you have any problem?
Yes, sir. আমার একটা কোশ্চেন আছে স্যার।
Yeah, Nias.
স্যার আমি কোশ্চেনটা চ্যাট বক্সে স্যার দিয়ে দিচ্ছি।
Okay.
স্যার এটা রেশনাল ফ্র্যাকশন নিয়ে। স্যার জাস্ট হিন্ট দিলেই হবে যে আমি স্যার কোন ফর্মুলাটা ইউজ করব।
Can you please again say the question? Integration of in numerator, what do you have?
x স্কয়ার মাইনাস
X square negative
29x
29x
প্লাস 5।
plus 5.
ইয়েস স্যার।
And then
দ্যাটস হচ্ছে x x মাইনাস 4
x negative 4
স্কয়ার হোল স্কয়ার x minus 4 হোল স্কয়ার হচ্ছে
Yeah.
x স্কয়ার প্লাস 3
X square plus
3
3.
yes
Okay, first of all, you can easily say that this is a rational function, right?
yes sir
So I'm going to my previous consultation part. Okay, so here a rational function may have two classification, proper and improper.
yes sir.
So you have to first understand that what type of rational function is this. Here you can see, if we just simplify, here we will get x square and x square. If we multiply x to the power 4, in upper part we have x square, in lower part we have x to the power 4. Definitely it is proper rational. Okay,
Yes sir.
Nias?
Yes sir.
Okay, so we can say that it is proper rational. And for proper rational, we have some techniques to decompose. That is, it is going with this part, x minus c squared. So for x minus c squared, what we can do? At first, x minus c will take a constant, and x minus c squared, then it will take another constant. And it has also the last part, x squared negative b. So for x squared negative b, we will have two constant, bx plus c. Nias, this is the combination of both step 2 and process 2 and process 3. Clear?
Then sir
So
I have to use the মানে দুইটা ইউজ করে আমাকে একসাথে করতে হবে স্যার
yeah, I am just decomposing here. So here you can see that in whatever figure we have here, if we try to find the integral, or if we try to find the answer of the integration or antiderivative, this is quite difficult.
yes sir
Okay, so for this we have to look for the right process, and the right process is method of decomposition. So what we have to decompose? We have to decompose this function. So how we can decompose this one? We don't need to think about the upper part. We don't need to think about the numerator. We just have to have a look on numerator. Okay, sorry, denominator. So here we have this one. So this one, it is going with this definition,
yes
x minus c squared. So at first write x minus c and then x minus c squared. So that's why I am writing here x negative 4 and then x negative 4 squared.
square
Okay,
yes sir
clear?
yes
So you can have a look on the theoretical part. So x negative c is containing a constant, x negative c squared is containing another constant. So for this, it will take a constant, suppose a. Since we are studying from a b c d, so we will go by this way, a and b, and then plus for this one, what will be the decomposition? At first write this one, that is, it is x squared plus 3. So since it is going with this formula, x squared negative b. So for x squared negative b, we will get two constant, bx plus c. So already we have taken b, so it will be cx plus
d
same format. Clear?
yes sir
So now what you have to do, already we have done the same technique previously, that you
Yes,
have
sir.
to multiply what the term that is in the left side denominator, that should be multiplied in both sides, here, here, here. Okay,
Yes,
so
sir.
in left side denominator we have x square, x negative 4 squared and x squared plus 3. So if we multiplying x negative 4 squared, x squared plus 3, so finally you will get x squared negative 29x plus 5 equal to, so for this part here, what will be the result? We are multiplying x negative 4 squared and x squared plus 3. So one part will cancel. You will get just x negative 4, right, Nias?
yes sir
Okay. So x negative 4 and you will get x squared positive 3. For the second part, for the middle part, b times, just you will get x
square plus 3
x squared plus 3. And for the last part, you will get cx plus d times x negative 4 squared, right?
Yes, sir.
So now try to find A, B, C, and D. And remember, finally, whenever you will find your A, B, C, D, then you may have to apply u-substitution method. Okay.
Yes, sir.
Okay.
Sir,
So
bucket
try to
farm.
solve.
Yes,
Yeah,
sir.
try to solve this one. And if you have any problem, then you can consult with me again.
Okay, sir. Thank you, sir.
Okay. So any question from assignment?
Sir,
Those who have
Sir.
missed my first consultation, you don't know that I have already discussed the theoretical part, and today this is the problem solving part. Okay.
sir.
Yeah, Jubair.
Sir, this say
Yeah, differentiation is okay. 3x squared. Then now we use partial. Integration by parts. What is your limit? Limit is 0 to infinity.
yes, sir.
But you have your process is wrong. Okay, because for 0 to infinity, you have to take limiting concept. Okay. Okay.
Oh, I have to change the limit also.
Yeah. Then what is your final answer?
Sir, unknown, sir. I don't know, sir.
Okay. It is one problem from improper integral. In my first consultation, I have discussed about improper integral. Improper integral deals with infinity. If you have infinity at upper limit, infinity maybe at lower limit, negative infinity, positive infinity, both in the limits, then these are not called proper integral. This is called improper integral. So definite integral means having lower limit and upper limit. Okay.
Yes, sir.
But if the limits are finite value, if the limits are defined value, then this is called proper integral. But if the limits are infinity, then these are called improper integrals. So where we have infinity, we have to take k or any variable, a, b, c, d, whatever you like. Okay, but that should be come up with limiting concept. Where we have infinity, use limit k tends to infinity. Where we have negative infinity, use k tends to negative infinity. Where we have negative infinity, positive infinity, we are using the same concept. And we have solved another problem here in last consultation, that is where we have negative infinity, we are using k tends to infinity. Is that okay?
Yes, sir.
Akash?
স্যার আমার
Akash,
হচ্ছে বাক্সের ভিডিওতে একটা স্যার সমস্যা ছিল।
Okay, so this is a problem from improper integral. At first you have to understand, figure out what type of problem is this, which concept will be applied. You have all these concepts. Okay, let me see here. It may be of rational function, it may be of trigonometric and reduction formula, it may be of integration by parts, it may be of improper integral, it may be gamma and beta function. But the problem that you have, it is of improper integral. Okay, at first you have to recognize the pattern of the question. Okay, otherwise whatever process you are applying, that is valueless. Okay, so you have to recognize your question at first, what category should be applied, then that process you can think about what is the process, and you can apply this and that related formulas. Okay, so now tell me your question. You have finally integration of gx e to the power negative x dx, right?
Yes, sir.
So what is your gx?
Sir, sir, gx is equal to first derivative of fx.
Okay, already you have found the first derivative.
Yes,
But
sir.
what is the value? What is the function for first derivative?
So 3x square.
3x squared. Okay, right. Dx, and you have the limits 0 to infinity. Is that okay?
Yes. Yes, sir.
So since we have 0 to infinity, so this is definitely improper integral.
Yes, sir. Okay, sir.
Suppose you have everybody has a specific name, okay? So that means this question is called improper integral. So here it is not improper rational. Be careful, it is improper integral, not
Yes, sir.
improper rational function. It is improper integral.
Integral.
Okay.
Yes, sir.
Okay.
So we
So here
can use the gamma function here, right?
for this,
Yes.
yeah, we can also take gamma function. Gamma
Okay.
function is the advanced technique of improper integral. See here, after 7 I have written 8. That means after improper I have written gamma function. Okay, so that means definitely gamma function is one kind of improper integral, but we can also solve by this way. So here we have infinity x squared e to the power negative x dx. Is that okay?
Yes, sir.
So since 3 is constant, we have pulled out 3 before. So first of all, don't think about the limits 0 to infinity. At first try to solve this one, the integral that you have. Clear?
Yes, sir.
And the same process we have applied for the same one, Jubair, for your first problem. We had
Yes,
the
sir.
limits 0 to 1, but we didn't take these limits into account whenever we are solving. Finally, after finding the antiderivative, we are applying the limits. Is that okay?
Yes, sir.
So same concept we will apply here. X squared e to the, already our time is over. It is 9:22, but I will give you another 30 minutes. Okay, just like
Thank you.
last consultation. Okay,
Thank you.
so here x squared e to the power negative x, because this is my last consultation for this week, and up I have another consultation after Eid vacation. Okay,
Okay, sir.
so now we have to apply integration by parts. Okay, so for integration by parts we have LIATE method. LIATE. So what is LIATE? Do you know? Here
No, sir.
L means logarithmic function, I means inverse function, A means algebraic function, T means trigonometric function, E means exponential function. Okay, so those who were present in my last consultation, you can figure out what I am saying. But for the beginners, for the newcomers, I am saying that this is the logarithmic function. So this process, LIATE, this process can be only applied for the integration by parts UV method. But we can think about whenever we have U and V, U can be taken up to this order. Suppose L comes first, then A. So L will be U. If we have algebraic term and exponential term, so A comes first, then E. Okay, so A will be U. So here you will understand from here we have the combination of x squared, that is it is algebraic term or polynomial function, right? And E
Yes, sir.
is exponential function. So which term should be considered as U? Definitely this
X
one,
squared.
x squared. So now
Yes,
we
sir.
can apply a technique, that is, you know, that integration of uv dx
Yes.
is equal to
Yes, sir.
u integration of v dx negative that one. Okay,
Yes,
so
sir.
here x squared integration of e to the power negative x dx negative total integration d dx of x squared or u integration of e to the power negative x dx and total integration. So what we are getting here, it is x squared integration of e to the power negative x dx. Do you know the formula? It is negative e to the power negative x.
Yes, sir. Yes, sir.
So here we are getting negative e to the power negative x negative integration of, now differentiation of x squared, first solve this one, it is 2x, and here we have integration of e to the power negative x, it is negative e to the power negative x dx. So you are getting negative x squared e to the power negative x, negative negative positive, 2 is constant, x e to the power negative x dx. Clear?
Yes, sir.
And now again you have to apply the same UV technique for this one. Okay.
Yes, sir.
So finally, I am not going in details. What you have to do, since you have infinity here, so have you understood the process?
Yes, sir.
Okay, finally, suppose it is I, so finally you will get your result I by using the same technique. But since we have infinity, so we can't avoid the process of improper integral. Okay, infinity always allows us to take limit, otherwise it will be a violation of the rules. Okay, so that's why what we can do here, instead of infinity, instead of improper integral, we are taking the help of a variable k where k is approaching to infinity. Is that okay?
Yes, sir.
Now 0, so instead of infinity we are applying k, so it is looking like just now proper integral this time. Okay, and already you have the answer for this one. So what you have to do here, okay, let me take another place. Okay, so what you have to do, 3, here you have limit k tends to infinity. Suppose finally you have the answer of your integration. Okay,
Yes, sir.
and you have the
Yes, sir.
upper limit k, lower limit is 0, lower limit 0.
Yes, sir.
Now in upper limit, lower limit, and then finally input infinity. Your answer may be infinity, may be a finite value.
Okay.
Okay. So by this process you can go forward.
Sir, I have
So
a question, sir.
okay, Jubair, I have taken 3 or
Okay,
4
sir.
questions, 2 or 3 questions from you. Okay, and for other one, then I am coming back to you, Jubair. Okay,
Sir, I've got a question, sir.
Okay, sir.
yeah.
Sir, it's
Document
like, yeah, sir, the question is x to the power 5, e to the power minus x square,
x to the power 5, e to the power minus x squared, dx.
and yes, sir, and the limit is
What is
0
the
to
limit?
infinity.
The
So I'll
limit
have
is
to
0
0 to
infinity.
infinity. So I'll have to
It
use
is
the gamma
also,
function here.
yeah, it is also improper integral. Do you understand?
No, sir,
It is also improper
I've been
integral.
asked to specifically use the gamma function.
But yeah, since you have been instructed to use gamma function, so definitely you can see from my screen that I have written after improper integral you are having gamma function. So gamma function is a classification of improper integral. It is the special category. Okay, so let me discuss this one. So from which set this is?
Sir, it's okay, sir.
This problem, you have found this problem in which
Sir,
set?
from set G.
Set G. Okay, so gamma function. At first, before starting this problem, we have to know what is the gamma function. Are you familiar with this notation, gamma function?
Yes, sir, I've watched the videos, so
Gamma
yep.
is not like this one. Okay, you are familiar with gamma, but this symbol is a lowercase. What we apply in here for this function, it is the uppercase. It is called uppercase. So gamma. So this symbol is now applied as gamma. So gamma of any number n is equal to 0 to integration from 0 to infinity e to the power minus x to the power n negative 1 dx. That is called the definition of gamma function. Is that okay?
Yes, sir.
And in my last consultation, I have discussed this one, that you will find this concept in this book, that is differential equation written by Danish Gill, in appendices section. Okay, in appendix 1. So this
Okay,
is
sir.
the gamma. So here, okay, now let me describe this one. It is the definition of gamma function. So keeping this definition in mind, we can solve this one. So what is the advantage of using gamma function? At first we have to understand this concept. What is the advantage of using gamma function? So here, whatever question Jubair has arised here, that is, it is improper integral, and we are using, for solving this improper integral, at first we are using integration by parts, then we are using limit, then we have to find the answer. So the process is going very lengthy. Is that okay? Is that okay?
Yes, sir.
But if we have directly one integral,
Yes,
suppose
sir.
integration from 0 to infinity e to the power negative x, x to the power x to the power 5. So for 5, can I write 6 negative 1 dx? Okay. So if we have this integral, we don't need to apply improper integral. Okay. We can also apply the concept of limit. We can use integration by UV technique or integration by parts. But since we have now gamma function, directly we can say what will be the result. That is, here we have e to the power negative x, it is going with this one, x to the power n negative 1, 6 negative 1. So the answer of this one will be gamma n, so gamma 6. Clear?
Yes, sir.
Now question is arising that what is the meaning of gamma? Gamma is nothing but gamma n is equal to n negative 1 factorial.
Yes, sir.
Clear? Or we can also write gamma n plus 1, because we can find factorial sign in a calculator. Okay, but there is no sign for gamma. Okay,
Yes.
so gamma 6 means 5 factorial. Clear? And now you know that how we can find 5, 4, 3, 2, 1. That is your answer. Clear? So
Yes,
that is
sir.
the advantage of using gamma function. If we can directly find the result, directly have 0 to infinity e to the power negative x, x to the power n minus 1 dx, then we can use gamma function. So we have another formula, that is gamma n equal to n minus 1 factorial, or gamma n plus 1 equal to n gamma n. In my last consultation, I have proved this theorem. That is, okay, let me show here. Gamma n plus 1 equal to n gamma n. Okay. Someone of you
Sir,
in my last
we
consultation have asked this question. Okay, so are you able to prove this one? Are you here?
yes sir.
Okay, Akash.
স্যার এই কোয়েশ্চনটা যদি সামনে যদি একটা যদি 5 যদি মাল্টিপ্লাই থাকতো তখন স্যার কি এইটাই স্যার আগে থেকে
If we have 5
yes sir
here,
5 into yes sir যে ফাংশনটা লিখলেন সেটা
so 5 can be pulled out here. 5 is a constant, don't think about this one. Okay,
স্যার তাহলে হচ্ছে গাউসিয়ান ইকুয়েশনে 5 তো স্যার ডিভাইড করে দিতে ওই সাইডে যায় সামনে 2 ছিল সামনে সে 2টা যে ওখানে ডিভাইড করে দিতে
okay. So let me solve this one at first. I am coming to you. Okay, clear? So since we have gamma n, the variable doesn't matter here. It may be instead of x we may have t. So x, so t n negative 1 dt. Is that okay? What
Yes,
I
sir.
have said, variable x t, that doesn't matter. That means gamma n is equal to, we can also write e to the power negative u. But be sure that this variable and this variable must have to be same. This variable and this variable must have to be same. Okay, so if I use u, so it will be u and n negative 1 du. Clear?
Yes, sir.
Okay, so for solving gamma function, that means definitely this is one gamma function. So for solving gamma function, we have to take help of u-substitution method, because you can see that in the definition of gamma function we have e to the power only one variable x. Clear? But here whatever we have here, it is not x, it is x squared. Do you understand?
Yes, sir.
So it must have to be converted to only one variable u or v or t, whatever we like. So since we are considering this x squared as u, the second step will be differentiation. So we are differentiating both sides, and then we are getting 2x, so du over dx. Finally we are getting x dx equal to du over 2. Clear?
Yes, sir.
So now I'm getting back to that one. That is, we have previously integration 0 to infinity x to the power 5, x to the power 5 e to the power negative x squared dx. Okay. So 0 to infinity x. What we have found for x? At first, have a look here. If x squared is u, then x will be root
Root
over
u.
u.
Yes, sir.
Clear?
Yes.
So root over u power 5. Okay, since this question is arising, so I am also trying to say this one, that you know that gamma 6 is equal to 5 factorial, gamma 7 is equal to 6 factorial, right? Gamma 4 is equal to 3 factorial, isn't it?
Yes, sir.
But we may have gamma odd number by 2, so we have to know how we can find this one. So I am trying to discuss this one later. I will discuss this one later. Now let's solve at first this one. So e to the power negative, this one is considered to be u, right?
Yes, sir.
So it is u. And dx, for dx, what you have found? Okay. What you have found for dx?
Du by 2.
Okay, we have to figure out this one at first. Dx is equal to du by 2x. Clear? So for x, what you have written?
Yes, sir.
Root u. Clear?
Yes, sir.
Okay. So du over 2 root over u. That means where we have x, we are converting that x to u. Do you understand?
Yes, sir.
Gamma
Sir,
function is the advanced gamma function. You have to understand the gamma function comes after all the concepts. Okay, so gamma function is the advanced one. You have to be very tricky in solving gamma function. So that's why problems are arising. You can see for x is considered to be root u. That's why root u is here. Clear?
Yes, sir.
So
Sir,
now let's solve.
so
Yeah,
when I
tell me.
solved this, I got to this part, but my question is like, I'm solving in respect to u, right? But
Yeah.
if I'm substituting x with u, then the whole integral changes, right? That's my question. Like, how's it even possible?
Okay, you will get your answer here. So 1 over 2 is constant. Can we pull out 1 over 2?
Yes, sir.
And then 5 by 2 e to the power negative u. Here you can see u power 1 by 2. We can bring this one as reciprocal, right?
Yes, sir.
So 1 over 2. Let me write e to the power negative u at first. Okay. And then you can see u to the power 5 by 2, u to the power negative 1 by 2. Can we sum up the powers?
Yes.
So 1 over 2, 0 to infinity, e to the power negative u to the power now 2. LCM is okay here. So that is, you are getting 1 by 2, 0 to infinity, e to the power negative u to the power 4 by 2 du. Clear?
Yes, sir.
So finally you are getting 0 to, okay, 1 over 2, 0 to infinity, e to the power negative u to the power, what is the answer? U to the power 2,
2.
right?
Yes, sir.
Now recall gamma function. We don't need to solve this integral. Whether we can directly apply gamma function. Gamma function says that if we have 0 to infinity e to the power minus u to the power n negative 1 du, then we can directly write gamma n. Is that okay?
Yes, sir.
So we have the same part here, but we need to rearrange just like this way. E to the power negative u, it is going with this one, negative u, okay. But the only change we need here we can see 2 negative 1, but here we, sorry, n negative 1, but what we have to do here, just to get 2, we can write 3 negative 1, isn't it?
Yes, sir.
That is the thing you have to do here. Okay, you will
Yes,
often
sir.
do a mistake in this part, but this is important. This is called gamma function. So
Oh,
finally,
sir,
yeah,
sir, I got this part, but sir, এখানে তো like x এর রেসপেক্টে প্রথমে ইন্টিগ্রেট করলাম না, এখন u এর রেসপেক্টে করতেছি, তো like আমাকে এখন u,
that is the advantage of using gamma function, that variable doesn't matter. I have already told you that it may be variable, maybe x, maybe t, maybe u. We don't need to solve this integral directly. What you can do, you can just try to use this definition, that is gamma, this one is equal to a number.
আচ্ছা, okay sir, got it.
Okay, so what will be the result here?
It'll be 2 factorial,
It's no,
3 factorial,
3 factorial,
right? 3
Sorry.
factorial.
Gamma
Sorry.
3. That means finally, yeah, you are correct, that 1 by 2 and 2 is 2 factorial. So finally 1 by 2, 2 factorial is 2, you are getting 1 as the answer.
Yes, sir.
Okay. So
Thank you, sir.
now, do you have any question from another set? Set A, set B, C, D, E, F, up to the last one. If you don't have any question, then I can continue.
Sir.
Yeah.
Sir, please can you check, sir?
What is your question? At first, try to tell me your main question from your PDF file. Then I will discuss this one.
Sir, it says the evaluate the following integrals by integration by parts.
Yeah.
I have to solve this by integration by parts.
Yeah. Then, okay, what is your u and what is your v? At first, tell me.
Here.
U is
U
this
equal to
one.
ln z. Ln
No.
z.
Okay. Show me the upper part. Upper part at first. Why you have considered 1 over z? Have you considered v as 1?
Yes, sir.
What is your u and what
Yes,
is
sir.
your v?
Sir, v equal to z, sir.
That is wrong. You have natural log of x plus 2 dx, right?
Yes, sir.
And integration from? Integration from?
Minus 1 to 1.
Minus 1 to 1. Okay, forget these limits at first. So here, again, we have, since you are instructed to apply integration by parts, so LI, we have to follow LIATE, that means logarithmic function. So integration by parts means we must have u, v, dx. That means u and v. U can be considered up to this order. Okay. So here we can see just only logarithmic function. So what is the v part? Can anyone guess?
1, sir.
V part will be obviously 1. So here we have ln x plus 2 times 1. We are considering that we have also a v, but v is 1. So now it is going with log L and 1 is algebraic. So this is A. So definitely u will be this one and v will be this one. Now try to solve by this way. That is integration of uv, that is u integration of v dx, negative differentiation of u integration of v dx, and total integration. Is that okay, Jubair?
Yes, sir.
Okay.
Sir, I have used this.
Yeah, I have seen, but finally, whatever you are doing, that is okay. That integration of z1 will be finally z, and I have seen in your copy z. That is okay. But you can't avoid 1. Okay.
Yes, sir.
Okay. So at first try to solve by this way. You will get your answer. And for your betterment, I am just giving you the answer so that you can figure out finally. 0 to 1. Clear?
So -1 to 1, sir.
Oh, sorry, -1 to 1.
Yes, sir.
And x plus 1.
X plus 2, sir.
X plus 2.
Yes, sir. Ln x plus 2.
Yeah. So finally your answer will be ln 27 negative 2. If we take the numerical value, then it will be 1.29584. Clear?
Sir, sir.
Yeah.
Sir, my answer is also, sir,
Same.
1.295.
Yeah, I have already told you that finally integration of 1 dx, you have written that is dz, that is you have written z, so that will be obviously right. But whatever you are mistaking, you are missing 1 at first, but actually
Sir.
that word is coming from 1. Yeah, Jubair, then
Sir, but sir, this is also the formula of integration by parts, isn't it, sir?
yeah, it's okay, no problem.
I mean, sir, where is the problem, sir?
Problem is the upper part, whatever I have shown here. Problem is in the upper part. Go to the upper part.
Yes, sir.
Yeah, that is ln z. With ln z, you have to think about that there is only one, there is 1. Okay, here you are doing that z 1 by z, and z you are automatically getting 1. That is the thing I am trying to say. But your process is correct, no problem. Okay. So any more question?
স্যার ওই যে গামা ফাংশনে গামা ফাংশন দিয়ে যখন গাউসিয়ান ইকুয়েশনটা যখন প্রুফ করতে বলতেছে তখন তো স্যার সামনে তো কোনো এক্স থাকতেছে না, তখন কি করতে পারি স্যার? আমরা যে সেকেন্ড ভিডিওটা যে সলভটা দেখা যাচ্ছে গামা ফাংশনের ওই জায়গাটার কথা বলছি।
I didn't watch the video, but try to tell me your question properly.
স্যার ইন্টিগ্রেশন লিমিট 0 টু ইনফিনিটি e টু দি পাওয়ার মাইনাস x স্কয়ার, এখানে স্যার সামনে কোনো x নাই, খালি
we can also apply the same technique. Whatever we have considered here, at first you have to recall your gamma function. Gamma function always takes e to the power only one variable, u, with power 1. But whatever you are getting here, you are getting x squared. So obviously x squared should be converted to u or v. Okay, now we can apply the same technique.
লাস্টে যে হচ্ছে এমন একটা ফর্ম আসছে যে 2 ইন্টিগ্রেশন অফ 0 টু ইনফিনিটি e টু দি পাওয়ার মাইনাস x স্কয়ার dx, এইটাকে স্যার তারপর 2 কে হচ্ছে ওই সাইডে নিয়ে যে 1/2 রুট পাই লিখছে,
because gamma 1/2 is equal to root pi. Can you remember I have told you that there is also another term, gamma odd number by 2?
yes sir.
So gamma odd number by 2, that means the formulas are gamma. At first try to recall that you have to know this formulas, that is gamma n is equal to n negative 1 factorial. This is the first formula. If we have gamma n plus 1, try to write down these formulas. Gamma n plus 1 is equal to n times gamma n, and then gamma 1/2 is equal to root over pi. So we know this very basic formulas with the definition 0 to infinity e to the power minus x, x to the power n minus 1 dx. These are the definition of gamma function. Okay, and the formulas are here. Clear? So keeping all these things in mind, you have to understand that suppose you have been asked to find gamma 7/2. You can see here we have gamma odd number by 2. So I hope that you don't have any problem in finding gamma 5. It will be obviously 4 factorial. Gamma 4, it will be 3 factorial, right? But what will be the case for gamma 7 by 2? It will be actually by applying this one. 7 by 2 can be written as 5 by 2 plus 1. Is that okay?
Yes, sir.
So we have n plus 1. So n can be pulled out. That means it will be 5 by 2, gamma n, gamma 5 by 2. Again, the same process will be applied. 5 by 2. 5 by 2 can be written as 3 by 2 plus 1. So again, 5 by 2 times 3 by 2, 3 by 2, 3 by 2. Again, 5 by 2, 3 by 2. Same process will be applied. That means 1 by 2 plus 1. So that means 5 by 2, 3 by 2, gamma 1. Sorry, it is 1 by 2 and gamma 1 by 2. Finally, we have to, calculation will be stopped if we get gamma 1 by 2. And for gamma 1 by 2, we have root pi. So finally, the result will be 5 by 2, 3 by 2, 1 by 2, root pi. So for your betterment, I am just now trying in details, that is trying to say in details, that is, suppose you have 9, gamma 9 by 2. It will be finally 7 by 2, 5 by 2, 3 by 2, 1 by 2, and gamma 1 by 2. And gamma 1 by 2 is actually root pi. So what will be the case for gamma 11 by 2? Can you please tell the answer? It will be 9 by 2, 7 by 2, 5 by 2, 3 by 2, 1 by 2, root pi. All these are in multiplication form. Okay, use calculator to get this value. Suppose you have gamma 13 by 2, it will be 11 by 2, 9 by 2, 7 by 2, 5 by 2, 3 by 2, 1 by 2, and root pi. Do you get my point?
Yes, sir.
So these are the things for gamma odd number by 2. But if we have gamma integer number, then it is n factorial, n minus 1 factorial. So that was what I am trying to say previously. Okay, and by this you can easily solve that. So for your problem, you don't have x to the power 5, you just have e to the power negative x squared, right?
Yes, sir.
And take the same thing. Okay, but finally problem will arise that you will get this type of figures, that is gamma odd number by 2, and I have discussed already what will be the result. You can go by this way, you will get the result. Okay.
Yes, sir.
Okay. So any more question?
চ্যাটে একটা কোশ্চেন দিয়েছি, একটু দেখবেন স্যার।
Okay, those who are present, please try to provide your emails on the chat box so that I can deliver the things whatever I am writing here. Okay, just like my previous consultation, please try to provide your email. Okay, so Juhair, you have one question. What's your question?
কোশ্চেন নাম্বার 6টা জাস্ট একটু বুঝায় দিলে হবে স্যার, কি করতে হবে অ্যাকচুয়ালি।
Oh, that is the new one. Okay, I am expecting just like this type of questions. Okay, you have finally forget about this one. Okay, does the answer surprise you? Okay, why do you think you got such a solution if you need to plot? Okay, can you solve this one? It is easy. First one.
এতটুকু পারবো স্যার, এরপর
Yeah.
কি গ্রাফিকে দেখাতে হবে না কি করতে
Yeah,
হবে?
you just have to draw the graph of sin x over 0 to 2 pi. But the problem is for the second question. I can see here you have modulus, right?
Yes sir.
So let me discuss this one. That's why I am asking some questions from you from different sets. Thank you, Juhair. So let's describe this one. And if you don't have any further question after that, then we can conclude the meeting after this problem. Okay? And before leaving the meeting, provide your emails on the chat box. So here you have 0 to 2 pi modulus sin x dx. Is that okay? Okay. So here, have a look on my first consultation part, that is, if we apply if we apply definite integral, suppose we have one integral with lower limit and upper limit, finally the value that is actually the area. Okay, what does it mean? That means any definite integral 0 to a f of x dx, that will be nothing but area. Okay, clear, Joher?
Yes, sir.
Okay, so first of all, let me solve this one. Then you will understand what you have to do for modulus. So for this, you already know that integration of sine x dx, that is equal to negative, the formula is negative cosine x. So here we will get the result negative cosine x, upper limit is 2 pi and lower limit is 0. Since negative 1 is constant, we can pull out negative for the simplicity of our calculation. So now we can apply the fundamental theorem of calculus. Fundamental theorem of calculus says that if we have integration from a to b f of x dx, there will be an answer f of x, capital Fx, with upper limit and lower limit. And what you have to do, that is inside x you have to input fb negative f of a. That is the fundamental theorem of calculus. And finally, whatever result you will get a finite value, that will be the area. So you will understand after solving this problem if I show you the geometrical figure then. So finally, after this integration, we have found the antiderivative, that is f of x, capital Fx. So that means here you have to input upper limit b. So here upper limit is 2 pi, right, Joher?
Yes, sir.
Negative cosine, lower limit, where you have x, in the place of x you just input the value of x. Okay, here upper limit is 2 pi, lower limit is 0. Now tell me, what is the value of cosine 2 pi? Cosine 360 degree is equal to 1. Negative cosine 0. Cosine 0 is 1. Clear? Is that okay?
Yes,
Try
sir.
to response. Okay, so it is 0. Finally, you can see that this integral is giving you 0. So that's the thing what I can understand from this one, that does the answer surprise you? We are saying that there will be one area, because suppose you have one region. If area is 0, then there is nothing. Suppose you have a rectangle, you have a plot, you can find the area by x times y. Is that okay?
Yes, sir.
But since area is 0, so what is the thing happening? Okay, so that means, so are you surprised? That is the question, that it has. Does the answer surprise you? Yes, we are surprised. Clear?
Yes, sir.
So next level, so why we are getting 0? We have done the mathematical part, but actually we have to figure out, we have to understand from the geometrical concept. Otherwise, we will not understand why our result is finally 0. So let's draw the function sine x. This is our function, right? So y equal to sine x. We have to draw the function from 0 to 2 pi. Clear?
Yes, sir.
So let's draw the function from 0 to 2 pi. If we input, suppose it is 0, it is pi by 2. Pi by 2 means 0 to pi, 2 pi means 0 to 360 degree. Can you figure out? So 0, suppose I am taking 90 degree, then 180 degree, then 270 degree, and 360 degree. That means 0 to 2 pi. Clear?
Yes, sir.
1 and negative 1. Okay. So if we input sine 0, if we input 0 here, what is the value of 0? Sine 0? 0.
1.
Right? Sine 0 is 0.
Sorry, sine 0, sir.
Now input 90 degrees. Sine 90 degree, here is the input. Sine 90 degree is 1. Clear? We are trying to draw the graph. Okay. Sine 180 degree value will be most probably negative 1. Sorry, sine 180 degree is 0. Is that okay? Do you understand what I am saying?
Yes, sir.
That means
Yes,
we
sir.
are inputting the values of x. X is 0, x is 90, x is 180, x is 270, and x is finally 360. And our function is y equal to sine x. So if we input sine 0, 0, sine 90 degree value 1, sine 180 degree value 0, sine 270 degree. Now tell me, what is the value of sine 270 degree?
-1.
-1. Sine 360 degree value is obviously 0. So that's the thing I'm trying to say. So here already 0 point has been located. 90 degree 1, it is here. 180 degree 0, that is here. 270 degree -1, that will be here. 360 degree 0, that is here. Is that okay, Johair and everyone? So we can draw the function sine x by joining all these points. Okay.
Yes, sir.
Now you can see that we have the area in above x-axis. We have the positive area, we have the negative area. So this area and this area are looking same. Is that okay?
Yes, total area is same.
That means in upper part we have positive, suppose positive 2, and in negative part we have -2. So positive 2, -2. Finally, you are getting 0. That's why we are getting 0. That's the matter of surprise. Okay. That means if you have area above x-axis and if you have the same area below x-axis, then these two parts will cancel out and you will get 0. This is geometrical figure. So since you have been asked to draw the geometrical figure here, if needed, plot sine x over eto. So already I have done this. Clear? Juhaya, try to respond.
Sir,
Yeah. Yeah, tell me. Do you have any question regarding this?
no, sir.
Okay. Now, the most important part is coming. If we have, this will be our last part, okay? And I will conclude the session within this one, after this one. So here we have modulus of sine x dx. So this time we don't have just sine x. We have rather modulus of sine x. And for this, those who are present in my last consultation, you know that I have mailed you that all these concepts can be found from these two books. Okay, that is Calculus by Howard Anton and Differential Equation part. We will follow this book. So from Calculus written by Howard Anton, here in chapter section 5.6, in 5.6 you have some similar type of problems in example section. Is that okay?
Yes, sir.
For everyone, you can see that for this part you have area above x-axis, area below x-axis, area above x-axis. Then some parts will be cancelled and finally you will get the result. So here for this problem, you can see, can you see that here we have modulus of 1 negative x squared?
Yes, sir.
Yeah. So if we have modulus over an integral sign, then we can't directly solve that part. We have to split up that function into positive and negative. You can see? And
Yes.
we have to draw the inner function, 1 negative x squared, 1 negative x squared. That is our question. So using that method, I am going to describe this one here. So according to that concept, we have to draw this function. Already we have done the same thing here. So From 0 to 360 degree. From 0 to 360 degree, we have drawn this function that y equal to sine x. Clear?
Yes, sir.
Okay. So you know that inside modulus there may be positive quantity, there may be negative quantity, isn't so?
Yes.
So similarly, since we have modulus sine x is somehow sometimes positive, it may be negative sine x. So where it is positive sine x and in which interval it is negative sine x, we have to find out. Clear?
Yes.
Already whenever I have found the points, that is from 0 to 180 degree, can you see? From 0 to 180 degree, we have positive part. That means sine x is positive from 0 to 180 degree. And from 180 degree to 360 degree, sine x is negative because it is coming below the x-axis. Is that okay?
Yes, sir.
So that's why if you remember, if you have modulus of x, then it must be once positive x, it must be another part that is negative x. So same thing we are going to do here. That means from 0 to 2 pi, that means 0 to 360 degree, we have some part 180 degree, where from 0 to 180 degree the function is once positive, and 180 degree to 2 pi the function is negative. That means this integral will be subdivided from 0 to, okay, what is the value of 180 degree in radian? It is pi, right?
Yes, sir.
So we are coming from 0 to pi once, 0 to pi. Just to get a total area, we have to add plus 180 degree to 360, that means pi to 2 pi dx. Now just tell me, from 0 to pi, what is happening for sine x? Is it positive or negative?
Positive.
Positive, so positive sine x. And from pi to 2 pi, that is 180 degree to 360
Negative.
degree, it's
Negative
negative.
sine x.
So finally we are able to reduce modulus part. So that means negative positive is becoming negative. So it is sine x. Now we know that integration of sine x dx, that is negative cosine x. So this time can you understand that here we have just sine x, but here we have modulus sine x. So this time it will not be 0, it will be some other parts. So let's see what we will get after this one. So integration of sine x, the result will be negative cosine x with upper limit pi, lower limit 0. Again for this one, integration of sine x, negative cosine x, 2 pi. Is that okay?
Yes, sir.
Okay, since we have the negative parts, we can bring that negative parts before at first, otherwise calculations will be critical. Okay, so here I am bringing the negative part before. So negative square bracket cosine x 0 to pi, and if we pull out this negative, that means it will be negative negative positive. So positive cosine x, upper limit 2 pi, lower limit pi. So now we use the fundamental theorem where we have x, these places are x, so we have to input upper limit at first, then lower limit. So cosine pi negative cosine 0 plus cosine 2 pi negative. Do you know why I am using negative sign? You can see there is a negative. It is from direct formula, fundamental theorem of calculus. So okay, cosine 180 degree, cosine pi, that is negative 1, cosine 0 1, plus cosine 2 pi, cosine 2 pi will be, cosine 360 degree value will be 1. Cosine pi, that means again -1. So we have -1. So finally we are getting -1, -1, -2, that means 2, plus 1 plus 1, 2. So that means 2 plus 2, we are getting 4. Clear?
Yes, sir.
So for the second part, result will be 4. For the first part, part A, result will be 0. So I hope you understood.
Thank you,
So
sir.
okay, this is the conclusion of our meeting. Yeah, Akash.
স্যার ওইটাকে যদি স্যার 0 থেকে π/2 পর্যন্ত যদি লিমিটটা ধরে নিয়ে তারপর সেটাকে যদি স্যার 4 দিয়ে যদি মাল্টিপ্লাই করে দিতাম তাহলে জিওমেট্রিক্যাল ফিগারটা দেখার পরে তাহলে কি হতো না স্যার?
Not 4. You have to multiply with 2. Oh, π/4. You are saying for π/4. Yeah,
না
yeah.
স্যার 0 to π/2 পর্যন্ত ধরে তারপর হচ্ছে
For
আমরা
0 to π/2, 0 to π/2, you have to multiply 1, 2. Okay, because you have 2 parts. But if we take 0 to π/4, that means 1 part, then 1 part, another part, then another part, then you have to multiply 4. But since we are using this one to this one, that is 1 part, another part, so you have to multiply 2.
0 to
But whatever I have,
লিমিটস 2π দেওয়া হতো স্যার।
yeah, limits are 0 to 2 pi. But since you have modulus, okay, so since you have modulus, so you can't avoid this one. You have to come up by this way. Don't try by that way. If you have just suppose sine x, then you can go by that process. But since we have modulus sign this time, so that is the wrong process.
আচ্ছা, ওকে।
So okay, thank you for attending the session. Okay, and
Thank you, sir.
okay, try to solve all the assignments and submit within the given time. Okay, so have a good time. So do you have any question regarding your assignment before leaving? Prantoras, Tasnia Juha, Sudipta Nondi, Aminul Haq, Ali Asghar Tamzid. Do you have any question? Pratik Bhomik.
No, sir.
Okay,
No, sir.
so have a good time.
Thank you.